not teaching actually. This is a discussion. We are going to discuss on the logistic regression, right? Is it logistic regression? Are you able? Oh, I haven't even shared the screen.
Yeah, it's logistic regression.
Yeah. Thank you so much. So I think you'll confirm, but for me, I always like engagement in the meeting, so that sometimes I want, like, for example, when you try to contribute or maybe to say something, I get some some word to say next. Like if it's just a monologue or a soliloquy, you find yourself that you are so tired and it wasn't even you can just be responding. For me, I always like that. Like you just respond in the background. Do we still have Ibrahim and Ian
Hey, good evening. Hi, good evening, man. How are you doing?
Yeah, I'm good. I'm good. Is it
This,
Ibrahim?
this is Ibrahim Ambale.
Oh, karibu sana. Or you should be the one who
No, no.
welcomes me.
Yeah. Welcome back, brother.
Okay.
We are
Thank you
from
so
this.
much. I'm so happy to join you guys once again.
Yeah, you're welcome.
Yeah. So, I don't know why my cursor always has issues. Once I start the recording, let me see if I think you guys are mature enough now to use VS. Not actually maturity in terms of age or like in the programming terms. You are with code. Because for me, I don't not code hangs and other stuff. Can I just to use because for VS Code?
Fine as well.
Who is that? Oh, is it PG? Naishumu watu wa kitambo. Maybe we have new people there. Yeah, so now I don't know why my cursor is so disturbing. So let me create a new folder for the project. Somewhere here. I want to create a new folder for tutorials or a discussion. Yeah, so the logistics used in the, like, it is most preferred when you are working with binary classification. So I hope I'll create. I can use now the notebook here. The file for a notebook is has the extension of what? Let me first of all say, like, a logistic. But I think it's IPNB. Is it this way? Python notebook. Is it that way for a notebook? The extension notebook.
Yeah.
I'll be using the notebook inside this VS Code. Wow, my cursor. Or I should have used even OBS to record instead of that iTop. I think it consumes a lot of memory. So as I said, like though we have other option of which you can use to work for, like, on the classification, like to work on the binary classification, including even you can even use the linear regression and also the random forest. But for example, something like the linear regression, that one is mostly for continuous data. and then the other random forest is not even convenient. You have to like, it's not much convenient. So basically the random forest is what is mostly used. For example, let me try to see if I can create something to illustrate somewhere. Mhm. I hope today I'll keep time. Let's see if I still remember this thing. Now, so you have to like, because for example, you want to work with which involves strings, which values which are not like, which are not values, which are not not values actually, which are not like numbers, and then you have to use like to convert it in, because in machine learning mostly you work with the values, the numbers. You work with the numbers. So for example, you want to like classify something, if it is a yes or no, or maybe how can I put it? Now let's assume that we want to know if someone is but then let me ask this one. This is just out of context. Let me ask, for example, does positive means something which is, should be embraced, or something which is in most cases should be, you should be like, um you should embrace? Is it in most cases like, for example, something if it's positive? For example, you have two options. You have the negative and the positive. So should we, which one should you choose like in most cases? Ibrahim, does positive means that it is something which is good in most cases? Something which is positive.
Yeah, I believe something which is positive, it means good in most cases.
In most cases, yeah, true, true.
Yeah.
But in some cases, so in some cases, not the case. For example, let's say, let's say I've gone to test my HIV and AIDS status, and then and then the doctor comes, and then I say, "Hey Nehemiah, I'm glad to inform you that you are HIV positive." Should that should I be happy about the output, or should I go and hang myself? So basically, in other words, we can say that the nini, you're like categorizing your like in classification. When you want to like to classify or to group things, basically it also depends on the context. Like for example, in the medical field, for example, you want to test something like the presence of cancer, or if it's not there. So if you'll get something like, for example, if there's a presence of cancer, then you can give it like something which is like you can give it a value like something which is like you can say one, or maybe positive, which means that there's a presence of that that disease. For example, if we like an example that I've just used, for example, you are going to test on the HIV and AIDS. So if it's there, then it means that you can give it a one. So it depends also with what you want to like test. So we can try. I think I'll use an example like for example, the one yenye tu nimesema hapa, for example ya kutest the presence of cancer. We can try to say that you are measuring the tumor size. The tumor size, for example, if it is a certain millimeter, it falls under the not cancerous, and if it's above certain millimeter, then we can say that it is cancerous. So for cancerous, presence of cancer, you can give it 1. Then the presence of not a cancer, you give it 0. So you'll have two binary choices. So you'll classify your nini based on like a two outputs. It can be, for example, true or false, negative or positive, or yes or no. But sasa this in the machine, you give, for example, something which is in the side of positive. For example, if it is yes, you give it 1. If it is something like, for example, ni true, you can give it like those sides zenye ziko na na nini, it's not like hiyo side yenye iko na nini at positive, like hiyo part yenye iko in agreement of something, you give it 1. You give it 1, like for example hiyo example ya kutest ugonjwa, so in the presence ya nini utaipatia 1. So that's how you can classify something. So nimefungua hii kitu but I'm not using it. So let's say you want to also, we have other, need to explain you these things in details by the with the code so that you can understand. Let me begin with my theories and then I shall get to the code. So assuming that we have, we want to identify multi-class, though this is not part of this discussion like in this topic, but sometimes you can categorize items more than not binary. We can have like several choices, but because in machine you have to classify items in numbers. So you can say, for example, you want to test if color is red. One is very terrible. Let's say hey, my cursor also it is something, and then blue. Is it green kwanza? Blue. What? Let me just code. Let me just use the code. I think. So let's say we want to classify on red, green, and blue. So you want to give it some values. Like if there's color red, you can give it a value. So in this case, for example, sorry, as. So hiyo inipatie kitu nataka this notebook ya hapa hivi, ama let me use just a normal Python alafu nitarudi kwa hapa hivi baadaye. Hii kasi yangu inajaribu kunisumbua kidogo, but like machine sijui inahanga ama nini. Let me see main .py. We have R, G, and B. So you want to categorize hizi zikuwa in the numeric. So in multi-class classification, you can give it, for example, nimegundua reason yenye iko nafanyanga ina run. I'm clicking on control and then nini. I'm clicking on shift then I click. Hapo hivi ingewaka. So unasema, for example you want to say that the color is red. You can say R utaipatia 1, which means that there is a presence of red, and then the other one utaipatia 0. So in the event, for example, green is available, which means that utaipatia red 0, and then green utaipatia 1, and then the other one utaipatia 0, which means that you only have the green. So you may classify this second one to be green. And then so mtu anaweza tupatia, anaweza to guess here what will be like for example the red, like a blue, not nini ya blue itakuwa nini, for example a binary for like some values to represent the nini this blue. Mtu anaweza guess what will represent like the values zenye zita stand for that blue. Are you still following, by the way?
0, 0, and 1.
Yeah, 0 and 1. So basically this is how you convert, like you can convert your string like these categories to be represented by to be represented by values so that you can use it in the machine learning. So I think this will be a topic for another time, but I think this time they said that like we're dealing with the binary choices. So we are going to deal on this one. So I think I'll begin with your example yenye nimetumia ya, for example, Kansas, you have to get to test if there's a cancer or not in our like you are testing if there's a cancer or not. Sorry. So what I'll do, Remember I told you that the logistic regression it mostly aims in solving the classification problems and mostly in the binary classification. It's not good in when you have like a multi-class classification. It's not a best in it, though it can also be used, but in this context we are using the binary choices. So because I didn't prepare a data set like to have a data set to use, I'll use just a random like some random values here, and then we'll work with it. But I believe you guys have understood. You understand how to use pandas, how to read, how to manipulate like a data set with pandas, and all those data manipulation. By the fact that you are not dropped, it means that you are good with pandas and all those other packages. And I think also we discussed about those packages previously. So I'm going to import my modules. So first of all, I think I'm going to import uh, NumPy to work with the numerical data. NumPy, NumPy, so we need to have sorry we need to have the feature variables, and also we need to have the response variable. Like for example, we can predict values and then get the response. So the feature inakuanga kwa x axis, then the response variable iko kwa the y axis, because we have two nini, we are using like we are using a binary option here. Like we are working in iko tu kama like it's just the same as the linear regression, where you have the x and then at the y axis. Let me get to that thing nione. Now let me by the way try to show you why the linear regression is not good like for binary choices. Like let me try to undo. So because hey, I'm not good in drawing. Let me try to kusingizia nini my cursor, my mouse nini vizuri is not stable. So because it's binary, we have zero. Zero inakata kujichora. Zero, zero, and then we have one because we are working with the binary. Sorry, nini yangu imekata juu ya hiyo nini, hii kitu hii ya recorder inatumia nini sana. Alafu ingine hapa hivi tutasema kitu kama 0. Sorry guys, please excuse my bad 0.5. So I'm saying so we have two choices. We have for example this is 1 2 3 ikiendelea hivyo. So utapata for example, because it is binary choice, for example let's say that we want to test like the percentage of people with diabetes. We can say that for example young people, they can't like their probability having diabetes is low. So you can say for example your values like at the age, for example you are measuring age again against the your diabetes. So utasema for example age ya between for example 1 2 3 mpaka let's say something like a 30, they are not under they don't have diabetes, so utazipatia 0 0 0, and then for example from that one, and this is just an example guys, it's not like mwingiliaring naingilia watu wa nini who are above 30 years abonyaka hapo hivi. So you can give it like your values, and then utapata the other one from 30 onwards zitakuwa saidia huku juu. So when you draw a linear regression itakuwa kitu kama hiyo, and you can simply predict, but you can find some other cases. You have someone who is very very old, for example someone that has 100 years, I'm not good in drawing. I could have illustrated very well, but it's not doing what I want. So, for example, something which if, for example, if you have like some edge which are not like mostly used in the prediction, for example, something like, for example, it is in the 80, you will see that when you want to draw your linear regression, you will have some, like you'll have like values which should be in the diabetes, but it is under the those who don't have the diabetes. Like when you have such values. So you'll find out that it will force you to look for another a kind of a distribution or maybe a function to work on such values. So we usually use the logistic function. Sometimes they call it logit function. So it will pick like this way. For example, these are those who don't have then it will form something like an S. So it will not, is it really S? It will go this, and then people will straighten, and then goes that direction. It can be predict because, for example, let's say you have like this is at the center. Let's try to let me try to do this and to draw this. Let's say our data points are passing here. Let's say they are passing here. Hey, let me see if this other one can draw well. Is it this one is to erase? I don't have the big pen. Let me see. We don't have the bold pen there, but it's just okay. So for example, your data point is, it is easier to get the values. So you will say that the values which are above 0.5, it will be directly get into like the one those who have the diabetes, and then those who don't have it will be for those which are 0.4 and below, like 0.49, is it 49 and below, but it's not like a 5. Anything below 0.5, it will fall under the. So this one will be a better one for the. This one will be the good one for like a binary classification compared to the linear regression, because in the event you have big outliers, then it can't be effective. Like for example, when you draw the line of your line here, it won't be that best for it. That's why we mostly use this one. So there's a function called a logit function, where it calculates like I'll explain that one as we go on. First of all, let me proceed with what I had started. So let me try to create here my my feature and what my feature and the response variable. So I can call it X in lack of better word, and by there is a good practice to give your response variable with capital or something, capital X. I'll use numpy numpy dot array. Let's try to think on some values which will represent Kansas, because this example I'm using there's something which is like Kansas. We are testing on Kansas. So which value can we use? Like for example, the tumor size. I told you that I don't like being like talking to myself a lot. You can even back me up. It's not even a mandatory, but I just want to see that engagement. And there's a lot of rain. I don't know if you are able to hear me well, or it is affecting you on your end. You're able to hear me still?
Yeah, we can.
Yeah, so you can give me some values to represent, for example, something which is not like if there's lack of cancer, like at the size of the tumor, which represent there's no cancer. By then we can decide, for example, let's try to decide.
Let's say 3 CM.
Yes?
Let's say 3 CM. 3 centimeters, 4 centimeters, 2 centimeters, size of tumor for cancer.
So between 4 and below, those are the ones that don't have the cancer, isn't it?
Yes.
And then the ones that are above 4, they are cancerous, right?
Yes.
That is so wonderful. So let me just use some values, including the decimal, for example, any random values, 2.3.6, or maybe the other one can use what? 2.5, 1.0, or let me say 1.6, whatever. Then one can be let's say 3 point whichever value, 3.8. I think that can be enough, or we need a more large. Let me try to increase a bit. So this one I can use, for example, something like a 2. Did I use 2 somewhere? 2.0. 2. I think I should be consistent. If I've decided to use one decimal, I should. And then 1.4. Then let's get to the ones that has cancerous. So we say that it is beginning from 4 onwards. So we can say, for example, 4.3 or a 4, sorry, and then another one to be. Can we use also 5, or maybe the size of the cancer can't surpass that one, or let it be in the range of 4.8, 4.3, and whatever. So how many are they? Because once you've defined the the values, the elements that are in your this X object should be the same as in the response variables. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's make it 10. It will be 4.9. So now the first thing that we need to make this one, we need to make this data to be to convert it into a 2D into a 2D array, two-dimensional array, for it to work we need to convert it to a two-dimensional array so that we may be able to work it. So we are going to reshape it. I'll use the reshape method. Reshape. So on the these are what we call these are rows, the rows, so it will be -1. So when you give it -1, it means that it is undefined. You don't know the number of rows it's going to have, and then you can give it 1 because this is just a 1. We only have we only have one category, or maybe something like that, or a classification. So it will be, so the first negative, it is standing for undefined number of rows, and then the other one is to stand for the column. You understand these things? And then now we can create also the response variable. The response variable, we shall use y, like it depends on the x. So again, we shall use the numpy array dot array, and then so now in this list, let's count which ones are negative. Negative, I mean that those that don't have the, is it HIV, the cancer? So 1, 2, 3, 4, 5, 6. So we say that the one that don't have, we give it 0. Can we give it 0, Cindy? We can give it 0. The ones that lack.
Yeah. Let us give it 0.
Yes, we can give it 0.
0. And then there are 6. Let me count 1, 2, 3, 4, 5, 6. And then let's see. So automatically the other one should be 4. 1, 2, 3, 4. Yeah, should be 4. So it will be 1, 1. So now you have binary choices here. So if there is a cancer, it will be 1. If there will be a presence of the cancer, it will be like any output yenye tutaipata ikiwa 1, like in our prediction, then it will mean that there is a presence of the cancer. And then you realize, for example, you are training a machine learning on, for example, something that deals in like in medicine. For example, let's assume that you are testing if someone has HIV and AIDS, and then you're using the wrong model that doesn't predict well, and then you unapata you've given someone that don't have HIV, but the output is positive. You will see you might cause someone to go and kill themselves, to kill himself or herself, and just on your initial stupidity, like your model is not that accurate. So this part should be like you need to like accuracy is what is most considered in binary classification. And that's the key thing. So I think another thing now, because we want to do the predictions here and the other stuff, we need to use the scikit-learn, sklearn, to do our prediction and all that, to train the models and all those things. So we say from sklearn, we can import. I believe I have this module in my system. Import. We can import the linear model. What's the spelling of linear model? Is it this one? Linear model. So guys, you guys still remember how to work with the modules. We discussed earlier, I think the other time, how to create the models and also how to create packages. You still remember how to do it, like how to use them? Great. I think I'll show you an example perhaps later, but at the moment, let me assume that you still know, because I wanted to like so this one is like we're importing like from this package, your scikit-learn, we're importing a module called the linear model, so that we may be able to import all the methods and the classes and the properties in this linear model. We're importing everything, but sometimes you can find that we are only importing the class alone. I'll also show you maybe later. So now we have this linear model we've imported here from scikit-learn. Then we can do it. We can train our data. We can train our model. So let's say logistic regression. I want to get something to use something that can for a variable. Which variable should I use here? Or a log R for logistic regression. Can it be that way? By the way, you guys, are you understanding? Are you following? Are you getting anything?
Yeah,
You are.
personally, I am.
Okay, great. So in this model, we have a method called not a method, a class called the logistic regression. So we need to instantiate or maybe to create an instance of that class. Let me show you an example of a class. Let me not guess that you understood that topic and yet you didn't. So let me create a simple one to illustrate how classes are used, or maybe how to import like a specific part if you want to import the class or the module, like the differences. So let me say, for example, person class.py, and then let me just create here a symbol class, or for example something like a person. I like using this example in most cases. And then let's initialize it with this init function init, so that we can assign properties to this person class init. Self dot self, and then our name, I just want to show you something here. I think I'll make sure that I'm in my time frame, like at the time that I was given. So self name, then the other one is age. Let's give values to these properties. So self name. So we are assigning, like we are creating variables for these properties so that we can like whenever we want to create an instance, we can give values to it. Like we want to make these properties to be like the variables. So the other one, it will be self dot age. Let me assign it to age. And then let me create a simple method here. Okay, sorry. If greeting. So to inherit the properties from this person class, this method we shall give itself here, and then let me say print. I just want to illustrate something here, so guys, you'll bear with me. Those who are good with this stuff, there are some people who needs to understand how we are using it that way. So let me say, for example, this is my sample. This is my greeting. Aman, let me say hello there. Hello, how are you? Let me say how are you. So now, for example, let me show you how this Nini to make us. So we have the modules like a packages inside the Python, which when you install, you just use them directly. And for example, let's say we want to use this, we want to use this module that we've just created here. A module is like the code library. For example, in your main program, you don't want to like write a lot of codes, so you can simply create a module and then I reuse them module like to use it in the main program. You just import what you want to use. So for example, in this case, you can say, for example, from let me make it inside a folder so that you can understand. Let me say, for example, main, and then let me just which one was our module? The person. So I'll say, for example, from main standing for this folder, which has the person module, assuming that it's a module. From main, import from main dot person. So it means that the first one we are targeting the folder, but in the context of the other one in a stand for the package, because we can as well make it a package. So this one stands for package, and then the other one stands for the file. Then for example, you want to import the class, you say import. Let me say import now the this person class. So you say import person. So in this context, this is the package name. The package is like the folder containing your modules, and then also you are importing the file called the linear model. Now, when you import the file directly this way, it means that you are going to import everything, including, for example, if you had the several classes or maybe methods or just function, then it's going to import everything, like where it's going to import like everything from this linear model. And in the linear model, we have another class, like in this file called the linear model, or this module called the linear module, we have a file for working with the logistic regression. So I'm going to say now a linear. When you want to use it, you begin with the file that has the package, like the code that you want to use, like the module name, and then a dot. And then it has a function. When you go to the documentation, you'll find that the linear model, it has the class for logistic regression. So I say logistic regression, and then it has some default value. Like now, for example, if you want to instantiate this person, let's try to create an instance of this person class. So let me say X. I'll assign it to, for example, person. I'm trying to instantiate, and then it was with the name and the age. So the first parameter should be the name, and then the other one is age. So I'll say, for example, Nehemiah, and then the other one is, for example, let me say 24. And then so we've just like instantiating. So if you want to create like an object like so we've just created here an object like an instance of that person class. So we can do it, we can create a variable for it so that we can print. So let me say, for example, so if you want to use it, you will begin now with this this object that you've defined. So it will be x dot, and then you call the method that you use there. It is greetings, and then you can say, for example, okay, let me just say greeting so that it can, or and then let me print y. So let me just try to see if I can. Ngoja. Y is not. Why it's not defined there? So I was trying like let me try to. It should work. I don't know the problem here, but the case here we wanted to, let me try to call it directly and see if it can do it. It can do what? Let me try to run. I don't know why it's not working at the moment, but let me. I was trying to like to show you like how you can use it in this case. For example, we have that module called. Let me get there. We have that module called the linear regression. Then we have the class called. So this way we are trying to instantiate like to give it some like to create an object from that class, and it has the default parameters. That's why you can give it an empty parameter because it has the. So you remember how to do the defaults in Python function? We discussed that one. For example, up if you call class, you give it the values. For example, the name, you give it like the values. For example, Nehemiah, and then age, you give it the age there, so that in the event you don't specify, it's going to inherit. No, age is an integer, 24. So in the event you don't specify, when you don't you don't want to specify here, then it's going to use those default values. So this is the same case that is being applied here. So in this logistic regression, we are trying to create an object, an instance of that logistic regression class, of which is going to from this we want to create that instance of that class, and then now because we have that object, then we can train now the data we have here. So we can say this object that we've created, log r, we can fit in our data. To fit is like to do what? It's like to train now your model. So I'm going to say dot that fit function. The function is going to train, is designed to train our models. That's why we have packages. They are they are, they simplify our process of doing many codes, because it already has the function to train our data. So in this fit, we are going to pass here our feature variable and also our response variable. So it is x, and then y. So in this case, we'll have done what we will have created trained our we will have trained it. So the other thing now we can do what we can try now to predict, because now we assume that we haven't run, but up to this point, when you run, you will have done what you will have trained your data set. This function, as I told you earlier, is to deal with training our train our model. So so let's try to predict something. Let's say, let me call it predict, or predicted, because I want to use something which is, because already the let me call it predict, or maybe let me call it predicted. Let me just use predicted. We can say we are targeting this value of which we've trained, we've modify, like for example, this first one we just created an object, and then this other one we've trained, like we've trained now that module. So this is the module that when you use that log r again, because while we were talking about the Python variables, they are dynamic. Like for example, if you create another thing after you've defined, like if you create the same variable and I give it another value after it is defined, then it's going to be updated. It is dynamic. So here, this one we are going to pass here this log r, which has the trained model, and then I want to predict something. So it has the function for prediction. So predict, and then we can predict what? We can predict anything. So let's try to predict something. Let's say, so we are going to use the numpy array dot, for example, array, and then we want us to predict something. So what can we predict here? Which value can we use to predict if it's cancerous? Let's see. 3 point what? Hebu mniambie kitu. Tell me something that I can use here. We want to predict what? Let's give me some values that we can use to predict.
4.2.
Yeah, 4.2. 4.2. Let's 4.2. Sorry. So let's try to see if now again we have to convert this one to a data frame, like to we need like to convert this one to be a two-dimensional array. So we are going to use the reshape function, and the reshape function, and then you for the rows, these things zinaenda na cross this other side, the rows, I'm going to give it again the indefinite number, which means that you can have you are not sure about the number of rows zenye ziko hapo hivyo, and then this column is 1, which means that it is now the column, single column there. And then let's try to print this value here, the predicted, and say print predicted. So let me run and see if our model is accurate or not. Yeah, it gives us 1, which means that it is cancerous. Up to that point, are we together? So up to this level, we've predicted that the tumor, which has a size of 4.2, is cancerous. When you have a tumor which is 4.2, it is cancerous. So you need to be keen, to prepare yourself psychologically to just to know that you have the cancer. So if you have a tumor that it is 4.2 millimeter, and then my friend, you have a cancer. And I'm so sorry for you. So now there's some things. There's something that.
I have a question, Emma.
Yes, please.
Yeah, cannot see your screen very well. Can you just go to where you did write zeros and ones?
Zeros and ones.
Yeah. You see, on our predictor variable x, those are like 9 values, and not 9, 10. And then on our y, the ones that are supposed to be predicted, to be estimated, they're also 10, but you started with 0, 0, 0, and then 1, 1, 4. So does it mean if you could have started with 1, 1, 1, and then 0, 0, 0, 3.6 will now represent to be cancerous? Because the way that you have arranged them, it gives you the answer. Because I did not understand. In fact, I was waiting once you finish, and then I ask, why did you start with 0, 0, 0, and then 1, 1, 1? Does it make any difference with starting with 1, 1, 1?
Yeah, there's no actually difference. In fact, this thing you can just randomize, but you ensure that the values that you've set, for example, if you've decided that, for example, 4 and above is Kansas, and 3 and below, no, 4 and below, no, anything below 4 is not Kansas, then the value that you give there should represent that one. Now, for me, I did this because I wasn't sure, like I didn't want to like go and check. I just wanted like to give the default, but we can try by the. Let's try to with a different thing. Let's begin with the 4, Sindo. 4.3, and then another one. Let's begin. Let's just try to randomize, and then this one we can give it what 2 point 2 point what
Even 2.1.
2.1, Sindo, and
Yeah.
then 4.3, 4.4 imekuja, and then what else? Give me some values.
3.8.
3.
5.2.
5.2. 5.2.
Maybe you can even do 2.7.
2.7.
1.1.
1.1.
How many values are we looking at? We need 10.
But there is a good practice to train your model with a lot of data set, but this is just for demonstration. In fact, the accuracy score is giving us something which is so accurate because we don't have like large data set to train our model with. But let's just go, let's use 10, around 10. 1, 2, 3, 4, 5, 6, 7. We can continue. Any other?
Should we surpass 5, maybe 6.1, 6.2, or will we have gone away big? Or we
I
just
think
stick?
I think we can have okay. I think we shouldn't have like a lot of outliers for our
Yeah,
data.
Then maybe we can do 3.1.
3.1,
Yeah, like
and then the force as few.
yeah,
We
the
use
4.
4 point what? 4.6. We used 4.6 somewhere.
No,
So how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. One more to go.
1.5.
4.5.
1.5.
Okay, 1.5. So, because we've said like 4 to represent something which is Kansas, so it's going to like it's going to because we want to train this thing, we want to like make sure those values above 4 represent the Kansas. So this one will be 1, and then the other one, this should be 0, right? It is below 4, and then this other one should be 1 because it's above 4, and then this other one should be a 0 because it is where am I? Able? Okay. This is the first one, second one, then this is
you
the
are
third.
on 3.8.
Or maybe you can give me some values. It seems I'm confused here.
3.8 is 0.
0, and then here,
That is 1.
1, and then here,
That is 0.
here,
That is 0.
mm-hmm,
That the next one is supposed to be 0.
0,
Then 1.
1, and then lastly,
Then 0.
0.
Yeah, in fact, Nehemiah, before you
Yes,
go on,
yes. Mm,
this is what I wanted to understand, because from what
mm,
I'm getting
mm,
is that you need now to align
mm,
your y variables
mm,
with the x variables. You cannot
mm.
now just start saying 0, 0, 0 and then 1, 1, 1. You need like to
Yes.
align them.
Yeah,
Yeah,
yeah. Mm.
thank you. I've now understood even my
You need
question.
to nini? Yeah. So
Yeah.
like let's try to put it in this way because a computer doesn't know. For example, you want to identify if someone is a person or a dog, a dog. So the computer doesn't know that this is a person or a dog. So you are going to say, for example, something that is using working with the 4 limbs. We can say it is a dog. So you have to give it precise, like exact what should be the output. You are trying to train it. And then, for example, something that talks. something that talks is a human being. So you have to give it exactly what should be expected. Like for example, you can say, for example, a human being to represent 1, then a dog to represent 0. So for example, if it is doing what? If it's walking with 4 limbs, we can say 0 representing a dog. If it is doing what? I'm confused here. So if it's talking like human with human language, you'll give it 1 representing a human being. So you have to give it, when you're training a machine, you give it exactly what should be there, so that computer will learn from how you are training it, so that in the future when it finds something similar to that, it's going to give you the output that should be expected. So when you are training your model, you ensure that you give it what should be expected, so that when you try to predict, like in the future, when the computer is trained and it wants now to predict, it will use the experience that you had given it, so that it can give you the outputs. That's why we gave it the exact what should be expected. So this part is a must, like to give it what it is expected. If you give it something which is not correct, then it means that the machine won't give you the accurate result. So you need to be precise whenever you want to like train your model, so that it can predict something in the unseen. Like for example, you have a data set which is like unseen. It can predict based on how you've trained it. So you need to be precise whenever you are training your your what in the classification, whenever you're training your model. So you give it exact feature so that it can give you what you want. So in this case, let's try to run and see first of all if it is corrupt or not. So you can see it still give you the result. Let's try to give it, was it 2? Yeah. So you can see it give us 0. And I remember it is more accurate because our data set is very, very small. And sometimes maybe you can have mistakes. Whenever you are training your data, you give something which is, I'm going to talk about sijui kama time it will allow, the confusion matrix. I can talk about it perhaps if time will allow, so that you can understand also. And there's some time whenever like you have something which should be, for example, if you are training a computer on person and a dog, and then you've identified something as a dog, and it should be a human being. So those things itakupatia some errors, like things which are not like shouldn't be expected. So I think if time will allow, I can talk about the confusion matrix, so that we can talk about those true positive, true negative, and all those other things, all those features. So any other question before we proceed? Are other people understanding? I want to see some feedback from. How many are there in the meeting? How many people are there? Am I logged out of the meeting?
No, you're in the meeting.
And the guys are not talking. And we have a good number there. Wow. It seems people still have the same energy.
Many people have given you thumbs up, so I think you didn't see.
Oh, when I'm in this part, I can't see the Google Meet. When I'm another window, I can't see. Yeah. So by there you can as well use the coefficients and maybe probability as well to test to predict still. I don't know if I should discuss that, or I should go straight to the confusion matrix, because I realize for me I usually have issues with time management. I don't know. What do you guys think? Should I show you, for example, to use, for example, the coefficients and also perhaps intercept value to like find if something is cancerous or maybe to predict anything. Or I should go
I
now.
suggest, Nehemiah,
Yes, yes.
maybe you can just use you can just show us, but use this data that we are using currently, if it's possible to produce the coefficients.
The coefficients.
Yeah, if this data can do that.
All right.
Yep.
So now I think let me. So this one to train our model up to this point. So this is okay. We've just trained our models, and then this other side we try to remove so that you may not get confused. So I want us like to create a function here. I want to create a function, and then we can use, for example, the the coefficients and also the intercepts, the intercept, and then we will try to see if we can get the we can get the if something is cancerous or not. Okay. So I'm trying to think on which one I should. Okay, let me define our function. Any other person to give us the function to use here? Like to work with their probabilities, like to use the probability to see if we can get the the output or not. By the way, there are some mathematics behind these things. Unajua Python it has simplified these things, but behind it there's mathematics. There's a lot of mathematics there. So any other person to give us the what? A function, just a function, any name. And the idea I just want us to be in that to like talk.
What do you want the function to do, Nehemiah?
I want to use here a function to see if I can be able to use the probabilities and the intercept, like the coefficient, not probability, the coefficient and the intercept to get like the probability, like to get the outcome to predict something.
So you can just call it predict function.
Wonderful. Predict. Let's go F. And in most cases, whenever you're using the functions, like it's most recommended to use the snake case naming convention. And then for classes, you saw me using capital P, Pascal case naming convention is most preferred. It's most preferred in that case. So, and also the variables. So basically, a function should be followed with these parentheses, and then we can now pass in here our log r, and then we can pass in now the x. Is it x? Okay. Let me just give it that way. Then I want us to now this function ya calculate the logistic regression ya kufanya logistic regression. Let me I'm trying to think on how I can explain this one. Like the function ya after the logistic regression itakupatia the logarithm of the odds, the logarithm of the odds, like of the output, like the what like if I want to get a linear regression, like a linear regression function ya kupata the log odds, logarithm of the odds. So let me just use something like the log underscore odds, and then let me assign it to that to the log to our trained data, and then here the coefficient I can just say, for example, coef. By the way, this method predefined kwa nini kwa scikit. Then I'm going to multiply by by x, and then a plus the intercept itakuwa log r dot intercept. So this intercept is also a building like a value ya kucalculate nini ya get like the intercept. I'll say intercept. So this is our equation, and then I want to intercept is it intercept alafu underscore. So I'm going to say here odds. Now I want to like convert because they are in logarithm odds, like they are the logarithm of the odds. So now we want to convert it to the odds, to the predicted, so that we can get we can do the prediction here. So for the odds, I'm going to use the numpy dot exp and then a log odds. So basically that function, you come and illustrate up it. Let me try to see. Now the goodness with the VS Code, it explain everything. Now this is the goodness of having the document.
Producer, reduce the volume. Give me.
So now we know that this equation, like the logistic regression equation, ni ya kupata the logarithm of the odds. So we want to convert that logarithm now to be the odds. So I'm going to use this exp to convert it. So I'll say log and seeing it may pass pale just so that we may convert it now to the odds. So for probability now, I'll say probability variable. Probability. Can I just say do we have the building keyword called a probability? I don't think. Probability. Is it the spelling for probability? Proper. Can someone tell me if that's the spelling for probability? Is it probability or a probability? You know, I'm a lawyer, guys, and you'll excuse me. There are some words that are difficult to mention. Is it probability? It's okay, right?
It's correct.
Yeah. So I'm going to say odds are odds over the 1 plus odds. 1 plus odds. So we want to get the I said odds. Odds, and then let's try to return the probability. Let's return probability. Sorry. Probability is here. And then let's call it. We'll see if we can get something like a. Okay, let's try to use this function to see if we can use that probability to get what the outcome, to test if something is cancerous or what or not, based on based on the feature variables. So I'm going to say here, let's try to print. By the way, I realize whenever I use the VS, like the Visual Studio Code, where I can't like just run. Unaona kwa nini kwa Jupyter Notebook, what just like for example, if I want to execute something, just call it directly and then it's going to get the output. But not VS Code, I don't think it works that way. You have to use the print if you want to see something in the terminal. Then for example, let's say log should be predict f. Then we are going to pass here the log. The log should be log r, and the log r, and then also we shall use the feature variable to represent this x, and then this one to represent the These are other one. This is this is what we call the there's something that I want to a positional argument. Like each represent one. Like this log R represent this one. Then this one you have to give it some values. It's not arbitrary, so you have to give it. So this one tutaipatia x. Let's try to see if we can predict. We can predict the. Let me try to run. We can predict. So this is the values behind the scenes zinatupatia nini, zinatupatia the results. Hizi zenye ziko hapa, let me see, 1 2 3 4 5 6 7 8 9 10. Yeah, so basically like tulisema the nini, we said that the regression function, like the regression what nini logistic regression function is to like get the logarithms of like it converts the output so that it can be either 1 or 0. That's why the output ulikuwa naipata ka 1 or 0. But now we've converted that equation so that it can be, we use this exp so that we can convert, so that we can get the odds there, like those the probability, the outcome. So this is how it was given us. So like for example, you can see let me see, the first one, it represent this 4.3. so you see it represents what this one, and then the other one, it is below 3, like no, it is what, it is 2, which falls under the 0. So this one, when you round it down, that's why it was giving us what, the 0 and so forth. So this was just like trying to explain to you how you can like as well use the you can use the probability like to see the output there of the prediction there. I don't know if we are together. Am I getting complicated? Should I go straight away to the confusion matrix? Or someone has a question? And you guys are always quiet. I don't know who usually teach. If this is how you guys usually behave, then it's tricky. Okay, let me assume you guys are good. Then I can go to the to what, the confusion matrix. So
Emma, is it possible for you to explain what these the coefficients mean?
The coefficients hizi nini, hizi functions nimetumia hapa hivi?
No, hizi zenye zime print out 0.6 blah 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 blah.
These are the real now the probability. Unajua sasa the logistic regression function may design in such a way that ukipata these values which is more than 5, then it convert into 1. Like equal into 1. Any value which is more than 5 itaipatia 1. That's why the output tulikuwa napata ka 1, and then the one which is below 0.5 convert inakuwa 0. Anything which is not above 5 itakuja kwa 0. That's why the output ilikuwa inakuja ka 0 na 1. So like this nini ita convert so that you get the real.
So basically unaona ka hizo value, hope Nigerians you're nowadays understanding Kiswahili. So like 0.6, unaona 0.6, then tuko na 0.65, tuko na 0.68, tuko na 0.86, then tuko na 0.74. Hizi zote zina represent hizo value zenye ziko converted into what, ndio
to have probability hizi zenye ziko pale juu, yeah.
Zenye as in ziko converted into 1, then hizi zenye ziko below 0.5 nasema ni other value yenye itakuwa 0.
Sorry,
only Ray understands Swahili.
I hope you understand Swahili.
Only Ray, please. Only Ray, not everybody in Nigeria.
Oh, sure.
Oh, God.
Pole. Sorry. I've used Swahili again.
Even Ray is having problems today.
Hey, whenever I come to your meeting, I usually bring issues.
Okay, let me. Okay, let me try to
Not like
explain.
that. Don't carry us along, please.
Yeah, I understand. I understand. That was just on a light note. Yeah.
Oh, okay, maybe Ijoma, if you have not understood, or any other person, maybe I can try to explain what we were discussing with Neymar.
Yes,
If you
yes,
have not
please. But
understood.
yes, I've not. That would go a long way to help me. Yeah, please.
Okay, Neymar, can you just maybe go up a bit so that we can see the X and the Y's? Yeah, you see those variables that we're having up there on the X. Anything that is above 4 or 4 and above will be converted into ones, and anything that is below 4, that is 3.9 and below, will be converted into zeros, meaning that we don't have presence of that disease. So if you come to the values that we have down there, Nema, can you kindly go down a bit? The values that we're having down there, if you try and check all the values that are at least 0.5 and above, like 0.6, 0.65, 0.68, 0.86, and 0.47, all these values can be easily converted into ones. So these are probabilities. So these values, they represent the ones. And anything that is below 0.5, like there you have seen you have 6 values, those will represent the zeros. Hope you have understood. This is in terms of probability.